Now let's look at one particular topic as one of the components of a program, which is the concept of a variable. We are going to start by taking the snapshot from a program that we have looked at earlier, right, which is the adding the sum of n numbers. This was used essentially in order to build up the concept of a computer, right, and essentially showing how we could construct machine language or assembly language programs. And what we said was, we assume that we have these numbers stored inside a memory, and what I want to do out here is to essentially write a program that will go access each of those elements one by one, add them up, and finally generate a sum that needs to get written back into memory again. Right. Now if you look at this program that we wrote, you will notice that, for example, right on the first step, I took some register r of 0 and set it to 0, right, and what I said is set up a counter. Okay. Now in the context of a programming language, in the context of assembly language, I do not have a choice. The only thing I can do is essentially use r of 0, because I need to specify which register to use. But for a programming language, perhaps I have a little bit more freedom, right. Instead of r of 0, if I could instead refer to it as counter, maybe that might have helped me to understand the program a little better. Similarly, r of 1 is once again initialized to 0. Quite frankly, in this assembly language program, by looking at these two statements, I do not know which is the counter and which is the sum, right. So if I could instead write a program where instead of calling it r of 1, I could instead use sum, that looks like it might be a bit more helpful, right. Similarly, this r of 2 is actually over here just a placeholder, right. What do I mean by a placeholder? It is something that is receiving a value being read from memory. Okay. So I have r of 0, r of 1, r of 2 being used inside my program, but at the assembly language level, it is hard to really know which is doing what. Right. If I could instead sort of say, okay, r of 1 use the word sum in order to refer to it, r of 0 use the word counter to refer to it, and r of 2 maybe placeholder or x, right, some unknown value, to at least indicate that all I am doing is loading something from memory into that. Right. This, in other words, is a motivation. What it is telling us is, when we are trying to write a program in a more abstract manner that does not go all the way down to the registers and the memory locations in your computer, we probably want names that a human can understand rather than the computer can understand, right. And the way to think about it is, what we are talking about are the distinction between names and values. Okay. How do we use names in such a way that a human can understand it and at the same time a computer can make use of it? And to understand that, it once again helps to visualize what goes on inside a computer, right. Remember that these set of registers are part of the CPU, right. Along with the ALU, they form the core processing unit, the central processing unit. But this memory is probably something external and quite possibly much larger in size, more capacity, right, many more things can be stored there. What I have marked over here are the different locations, right. So there are many different locations inside memory. Similarly, there are many locations in the register file, as we call it, right. The locations inside a register file are usually just called registers, whereas the locations inside memory are called memory locations, right. We do not have a better word for that really. Now if I could declare things like counter or sum or first value and use them to refer to different memory locations, right, now that suddenly becomes a lot easier for a human to understand than things like mem of 0, mem of 1, mem of 2, or r of 0, r of 1 and r of 2, right. You might also see that I am using a word counter to refer to something out here, and there is also another counter sitting in the register file, right. That is entirely possible because the registers are sort of a temporary duplicate of what is there in memory. So it is quite possible that I have something which is a sum which is stored in the main memory and at the same time is also being used as some internal register, right. The bottom line is that these are names that we give to these different locations, which makes it easier for the human to understand, right, rather than for the computer. The point is that the compiler, which then goes through this program that you have written, can easily translate between those human understandable names and something that a computer can understand. So effectively what we are doing is the concept of a variable is essentially a human readable name, right? It is an alias, some way of referring to a memory location or possibly a register location, basically a storage, right? It is, in other words, a name that is given to the data that is stored at some address. More importantly, you can actually think of it as it is the name associated with a given address. This is the important part over here, right? The data itself might change. So the name does not change if the data changes from 5 to 36, right? The name still remains exactly the same. And that is where it becomes useful for the humans who are actually writing the code. Now, there are a number of different naming rules that come about in the context of how we write programs, right? These are specified as part of the programming language itself, okay? And what we have over here is, for example, there are you are allowed to use alphabets, right, A to Z. Of course, you will notice immediately, right, I mean there is a clear bias towards the English language, and part of it is a lot of early computing really became popular in the United States, which means that a lot of the conventions that we have are built around those languages, right, or the English language, right. So things like, for example, A to Z is allowed as characters to be used over here, capital A to capital Z is also allowed. The digits 0 to 9 can also be part of the name of a variable, right. The character called the underscore, right, is also used as part of the name, can also be used as parts of a variable name. And the reason why this one in particular is used is because one character which is not permitted as part of a variable name is the space character. In other words, if I wanted to have something which says a counter to hold a temporary value, right, I can't write out the name like a counter to hold a temporary value because that is multiple words that would be separated by spaces. And the way the C language works is the moment you have a space, it assumes it is a different token, right, or that it is a different variable name or a different function name or something else. It essentially splits on whenever it finds spaces, right. That was a choice made for simplicity and it is a reasonable choice, right. The implication of that, of course, is that you cannot have variables containing space as part of the name, but if you do want a readable name, the underscore is a reasonable proxy for that, right. It allows you to sort of separate out the different parts of the name without using a space explicitly. There are a few other rules out here, right. For example, you cannot start the name of a variable with a digit. It has to start with either a lowercase or uppercase character. It can start with one underscore but not two, right. So there are a few more rules out there. I strongly suggest don't try and explore all the rules in actual programs that you write, right. There are more rules than you can actually sort of exhaust out here. Always prefer simplicity in naming conventions, right. If at all you need to sort of have a longish name, use underscores if necessary. There is also something else called camel case, right. So the add nums, for example, that I had shown earlier follows that, right. Effectively what it says is something like this. If I have a name like add nums, right, so this is lowercase, then there is uppercase, and once again I have lowercase, right, and this is sort of supposed to be like the hump of a camel, so it is called camel case, right. The alternative to that would be something called add underscore nums, right, which is sometimes also called snake case, right. So rather than worrying too much about what these are called, pick one, go with that preference. It is quite possible that depending on where you are programming, if you are programming as part of a larger project, there may already be guidelines on how to go about naming variables. If so, follow those, right. So these things can be, like I said, context dependent and program dependent, meaning that if you have a large project where multiple people are working on it, somebody usually sets overall guidelines on how to go about naming variables, naming functions, etc., so that it's easy for others to understand. Right? Now, one other thing, modern versions of the C compiler can also handle things that are not restricted to the English alphabet. Right? In particular, you can use certain Unicode characters as part of variable names. Okay? But this is once again something that is highly, it's not entirely compiler dependent, but is not something that is very commonly used. Once again, please use caution when using this approach, because it is quite possible that what you are using on one compiler may either end up not working properly on some other compiler, or more importantly, it might be taken over by somebody else's system, or it may be run on somebody else's system where the corresponding Unicode characters, definitions and display symbols are not present. Right? In some sense, what we have over here is sort of a a common denominator, right? A minimal subset that everybody should be having on their systems and can use in order to write the programs. So, at least for the context of this course, definitely all variable names should restrict themselves to something as a reasonably simple variant of what we have out here. You cannot have a variable defined in C without also specifying what type that variable is, right? And the data types are something that we already looked at before, right? There are integers, there can be what are called short integers, which are only 16 bits in length, 2 bytes in length, right? There are what we call char, right? A char or a character is usually just 8 bits or 1 byte in length, right? It's usually called a char because it corresponds to a single ASCII character, but it can also be used as a number, as an 8-bit number. Right? Apart from that, you also have floats, doubles and so on. All of these refer to different kinds of numbers. Apart from numbers, you can also have other kinds of data types, right? And the important part is that all of these are essentially just referring to some kind of an interpretation of bytes that are stored in memory. What does that mean? It means that, remember, what's a variable name? It's a sort of alias to some particular location in memory. And if I say in addition that this variable name corresponds to an integer, you will know that when you go to that particular location in memory, you need to look for 4 bytes, take those 4 bytes together as a 32-bit value, and that is the actual value of the integer that you are interested in, right? So, the type combined with the name, which translates into an address, is what actually tells us how to go and interpret something that is present in the memory of the computer. One thing about the type declarations is that once you declare a variable to be of a specific type, you cannot change it again within the same program. That's not entirely true. You can probably have something else declared with the same name that essentially comes under something called the scope of a variable, but we will get to that later, right? For simple programs at least, the a good way of understanding it is that once you have declared a variable, you cannot change it. What can you do with variables? You can assign values to them. Variables are placeholders. Remember, they are aliases of some locations in memory, which means that I can use that alias as or that name in order to update or set a particular value in memory, and that is exactly how C uses it, right? C essentially allows us to update values in memory by essentially allowing us to assign values into variables. One other thing that happens in C is that it sort of tries to recognize the fact that the different numeric data types, integers, floats, shorts and so on, are all numbers, right? Which means that implicitly the compiler will help you with doing certain simple things. For example, if I want to convert from an integer to a floating point number, or a floating point number to an integer, or from an integer to a short integer or a character, or the other way around, there will be some automatic type casting, right? In general, that is restricted only to numbers and certain very specific data types. it is also something which you need to be a little careful about. Although it's convenient as a programmer, it can also lead to potential problems if you don't use it carefully. So one other question that might come up is, who decides the location of a particular variable, right? In other words, how do I decide that this variable which I have called sum, let's say I want this particular memory location to have the value sum, right? The short answer is I don't have that level of control. The compiler, the programming language doesn't give me that level of control in general, right? I can't easily say that I want this particular location to be called sum, right? What instead is done is I say that I want the space for storing an integer and I want to give it the name sum. The compiler combined with the operating system decides that some location in memory is available and might decide that this particular place is going to be called sum. The point is you don't really need to know as a programmer, right? All memory locations are more or less identical in terms of their behavior at least, right? So as long as that is the case, the language basically says this is not under programmer control, and part of the reason for that is portability. It should be possible for you to write a program without having to worry about whether a variable got stored at this particular memory location or somewhere else, right? And that is one of the key sort of abstractions that a programming language provides you. You don't need to care about the individual memory locations and what they are called, right? So the compiler and the operating system together will decide where things go. How exactly this is handled is actually one of the important parts of how the C programming language works and is used, and is something that we will also get back to later again. One more word about another data type which is not really common, right? In particular, right, you might imagine that this thing where I want to check certain conditions, is a particular variable less than 10, or is an expression like I plus 3 greater than j by 2. Okay, so I and j are both variables in this case, and I want to do something with I want to do something with j, I want to compare their values, right? So I would expect that this particular expression that I have out here has its own data type, which is true or false, right? But it turns out that in C there is actually no separate Boolean data type. Okay. If you do want a Boolean data type, there are some headers that you can include that will allow you to declare something called bool, but that's still sort of effectively implemented as an integer, right? What C does on the other hand is that any value which is 0 is treated as false and any non-zero value is treated as true, okay, which is actually quite easy to understand and easy to make use of, except that it can potentially lead you to problems, right? In particular, look at this particular statement, right, which again, if you are not familiar with what an if statement is in C, we will get back to it again later when we talk about control flow, but logically you can sort of imagine what this is trying to do, right? What it says is if a is equal to 3, do something. When I look at a code like this, the first thing I assume is I have a variable a, I am checking whether its value is equal to 3, and based on that I will decide what to do out here. But that is not what is going to happen with this particular piece of code, right? What will happen in this case is that I will actually take the variable a, I will assign the value 3 to it, right? Now is when you notice that this is a single equal sign and not a double equal sign, which is actually used for checking equality, right? Since it assigns this value, right, and since a is equal to 3 is also an expression in C, right, which returns a value of its own, right, what ends up happening is that this effectively becomes if 3 is non-zero, so it is true. So if 3, do something, which basically becomes always true. Now this kind of statement is, writing code like this is basically called shooting yourself in the foot, right, and a nice colloquial term for it is that this is called a foot gun, right. Please be very careful when writing code of this sort, right. The fact that you can treat assignments as expressions and the fact that there is no separate Boolean data types can combine to get you into a lot of trouble if you are not careful about how you are writing code, right. Once again, the general principle over here is C allows you to write a lot of really confusing code. It also allows you to write elegant and easy to understand code. Now it's up to you, right. Always prefer as far as possible to write simpler and more understandable code where possible. Now, apart from all of this, of course, we have some basic input and output helper functions, right, which you will be using as part of some of the assignments at least that we have. And what we need over here, at least to start with, are two very simple things. We have already seen printf, that was used in order to print information onto the console, right, which basically comes back as something for the user to read. There is also another equivalent or rather a similar function called scanf, which does the opposite. It takes input from the user and takes it into the program, right. We also saw a brief overview of format strings, right, where a format string is essentially something that basically says, if I want to print data out with some numbers in between strings and so on, how do I format everything together in a clean manner, right. That is once again a very useful facility and is something that we'll make extensive use of. Some of these things are, there are just too many details out there to really cover as part of a lecture. So there will be documentation on on the different kinds of format strings that can be used, and you need to sort of go through those and understand the different ways by which you can use those strings.